not gonna. If it's like this, then you can say prime all day. That's beautiful. That's perfect for art class. Later classes, depending on the teacher you get, maybe you'll actually learn. You can totally factor that. Just it won't look pretty. You can totally factor this. It really won't look pretty. This one would be remarkably disgusting to factor, but it could factor. Let me go ahead and give you the answer key. So, look that over. I even used different colors on this thing. It's crazy. Just on that one problem.
Is there going to be long division on this?
What do you think? Yes. It's a good answer. Even if you said no, there will be. There will be long division.
Those are complete. This one I complete, so better than nothing. I couldn't.
Oh, okay. Sure. That's good.
Did I just go over to long division?
No, nobody's asked a question about long division yet, so.
Can you go?
Sure.
Let's do a couple of 20 of them.
Thank you. So it's going to come out the rest of that. Yes. Oh, yeah. So if this was you would just separate. Because the bottom is one term.
One term.
The minute the bottom is more than one term,
Division.
that's where long division comes in. It's the only way to do it.
Again, please.
I'm not missing any terms, right? So I don't have to put a 0 in anywhere. I'm not going to do that to you anyway, I think. I'm not going to do that to you. It's already hard enough on its own. So you'll have all the terms you need. You won't have to put a 0 in, but I want you to realize that is a method that you might have to use at some point in your future. So x times what is x cubed? X squared. X squared times x? That's amazing. We just said it. X squared times 5?
5x.
And then you
Change the sign.
change the signs.
This one cancel.
Those always have to cancel. It tells you on the right track. Negative 4x squared minus 5x squared.
Negative 9 squared, x squared.
X times what is negative 9x squared?
Negative 9x.
Right? What do you need? You have an x. Times what? Well, I need a negative 9 and then need another x to make it x squared. That's how you piece it together, right? So then negative 9x times x is that. Of course it is, because that's where we got it from, right? And negative 9x times 5, negative 45x. And then you change the signs. Those cancel like you're supposed to.
45x.
46?
X.
X.
Yeah.
Minus 7.
X times what is 46x?
46. 46x squared. 46. 5, 13.
150. 5 times.
5 times 40 is?
20.
5 times 40 is?
200.
5 times 6 is?
30.
230. There.
200.
And then you change the sign. Those cancel. Negative 237, so you put minus 237 over
Plus 5.
x plus 5, because that's what you were dividing. Oh, shit. I desperately want you to see how that's exactly the same as normal long division. I just did everything I would have done if there would have been numbers instead of letters. All the steps I did, exactly the same. And you're all like, nope. It looks different, but if you think about every step I did, it was exactly the same steps. The steps were the same. The stuff I'm using looks different.
Wait, how did you get the 230?
The what?
What if
That? Oh yeah, it's 46 times 5
And then you got 230.
was 230, and then I changed the sign. Yep.
if there is no reminder, like it's like go to 0?
Then if there would have been, you would have just stopped there.
That's it. Okay.
And that means that times that would be this. You kind of factored it. It's kind of neat. If it goes in evenly, you actually just factored it.
Here's another one, please.
So you guys do this.
When it close will be the test.
Let's try that one then. I have somebody's section 6.2 and 6.3 homework. The person who I thought it was, I was wrong, so I'm not sure who it is. Oh, it might be Azra?
Azra.
When you turn in 6.2 and 6.3? Not yet, okay. You're okay. I'm just trying to figure out who's that right. So it might be you. Wait a minute, let me see what happens. Oh, here you go. See, I got yours. Think? Yeah. Annalise. Jacob. Alicia. To get people tomorrow. A lot of people show up tomorrow. They won't even look familiar to me. That's what I hate, man. You're in my class.
Yep, so you.
Let's see if it does what I wanted it to do. Yes.
Does the variable or does the term like this right here, does it have to be one term to be division? Or does
No, if it's one term, then I don't have to do long division. I can just break it up.
Yeah.
If it's two terms or more, I have to do long division.
Okay. So what about 1b then?
1b?
Yeah.
Well, that's a different kind of problem entirely. I mean, the negative power means flip and then
Okay.
square it. Yeah.
Yeah.
Cool. All right.
You're right.
So what do you got? Good. X squared times x, that's q. X squared times negative 1. Negative x squared. And then you
Change the
change
sign.
the signs. And this is where people really started to
Negative.
forget how to add numbers.
Negative.
Like if people tell me that's negative 4,
No.
like if people tell me it's positive 2, and then the whole thing goes to shit, right? And again, the way I grade anything is the process is the most points, and then the right answers and the right numbers is less points, right? Some points. So as long as you do the right process, if you put negative 4x squared there, you're going to lose something, but not a lot. But here it should be
Negative 2.
Yeah.
2x.
X squared plus 3x.
x times what is negative 2x squared?
Negative 2x.
Yeah, negative 2, and I need another x. Cool.
Negative 2x squared.
Negative 2x times negative 1,
2x.
2x. And then you
Change the sign.
change the signs.
Have to cancel.
3x minus 2x.
X minus 1. 1.
X times what is x?
1.
1. 1 times x is x. 1 times negative 1 is negative 1. And then you...
Change the sign.
So because of the last question that somebody asked me, I wanted to make one that had no remainder. And I take complete ownership of the fact I made a problem that had no remainder. Yeah. So what does that mean then? This times this
Exactly
is
this.
this. Exactly. So we just factored this using long division. What? Can you see this? Look at this. If you try to group this inside, would that work? No. Can you guys see how it wouldn't work? You take an x squared out of it, and you have x minus 3, and then nothing comes out, 3x minus... Oh, shit, it wouldn't work. So long division saved my ass there as far as factoring it went. I would have been okay with never knowing how that factored. Shit. But I just want to show you that long division does have a purpose. If you make it into 110, into 176, one of those two, depending on your teacher, they're going to show you a shortcut for this. That I'm not going to show you. It's too bad for you, how? Because the shortcut's a little weird. It makes it quick and easy, but it's a little weird to understand why it works. Yes?
So when I did it, my answer started off right, and I don't know where I went wrong. But then again, I never used an X, I used a 1, and it still gave me where I
So you put an x squared there. So x squared times x is x cubed. X squared times negative 1 is minus x squared. Uh-oh. So see, look. No. But you can't add these because they're not like terms. So that would be a big problem. Yeah.
Are we getting the able to use a regular quizzes?
Yes. You guys are funny. I shouldn't let you now. Sorry, I'm not. I'm going to let you. But man, it just makes me cry. I know it's only math teachers, but 7 times 8. Somebody's reaching for the calculator. Human race needs some help. Come on. Yeah.
Just 3C, under in the practice test. So you wrote no. Why is that?
So what can a polynomial not have? What would it have that would make it not a polynomial?
Oh, negative.
Well, negative power, but more importantly, a variable on the bottom. So if I do have a negative power thing, isn't that a variable on the bottom? In disguise, right? Problems in disguise. So that's why part C is not. But why is part B okay? Why is 3B a polynomial? It's got a fraction in it. Oh shit. But what's on the bottom of the fraction in 3B? 3B. Does anybody want to play along with me?
3.
Yeah, so it's fine. See, there's no variable on the bottom. So it's not, does it have a fraction? It's, would it have a variable on the bottom? And part C would. You bring those 3 W's down, oh shit, it's not a polynomial.
So when you ask about the leading coefficient, you mean each term?
No, let's see. I can't remember if this is something the book brought up or not. I might not ask that, but like if I saw this, can somebody tell me what's the degree of this polynomial?
This one 5.
5th degree. So the leading coefficient is the number in front of the highest degree term.
Minus.
That would be the leading coefficient, not 4.
Yeah, okay.
Because is this in order?
No.
So that's why the leading coefficient is the number that would be the first number I see if it was in order. So that's why, in all these, I think I put them in order. So, the first one, the highest power, is the first term. So the leading coefficient is 1. Let's see. Is anybody else? No. They're all in order. So it's just the first number I see. Okay, maybe. Which one, sir?
Because it's a negative?
3C?
Yeah.
So again, a polynomial can't have a variable on the bottom. So like this
Oh.
obviously is not a polynomial, right? Yes?
Right.
You're like, yes, because you said so. Yes.
No.
But how can I rewrite this? Can I bring it up and make it -1?
Yeah.
Did I just sneak it past the, you're not a, wait, you do it fine. And it's still not a polynomial. That b would be on the bottom, so it's still not a polynomial. Just because I wrote it to a negative power doesn't make it sound like fine.
So what will happen if we multiply all with b? Multiply with
Well, then you'd have a
to
different
cancel.
problem.
Uh-huh.
Sure.
To
So
cancel
your
b.
question then would be, what if it was a different problem? Then it might be a polynomial, sure.
Uh-huh.
Right? I'm sorry, I'm being a little bit short, but if you multiply by b, you made a new problem. So that you're not allowed to just bring that in. All right? And again, can somebody tell me can b be any number I want it to be in this problem? Can b be anything I want it to be?
Yes.
You sure about that? Think about it for a second. What is b doing?
No,
Dividing. Oh
yeah,
shit.
Not 0.
Can't
right?
be 0.
Mhm.
So that's why we have the rules. I want a polynomial to be defined everywhere. I want it to be a nice function, not look all weird when I graph it. This function is going to look weird at 0. This function actually is going to look like this. It's going to, oh shit, it can't be 0, so it's going to all freak out. It's not going to look nice. I want a polynomial to work for any
For
value. And that's fundamentally why I can't have a variable on the bottom, because then maybe some values don't work. Okay.
I need to go,
Yeah, I was gonna.
go back really quick to D on the same section. I thought I understood when you explained it, but so I thought that you had to have a variable for it to be
No, what can you not have?
a negative.
You can't have a variable on the bottom. Does 5 have a variable on the bottom?
No.
No.
So
In fact, another way to say a polynomial is all the powers have to be whole number powers. So that makes sense now. Is that a whole number? No, it's not. It's an integer. It's a negative number. So it's not a polynomial for that reason also. So 5, how many variables do you see in there? None. So isn't it... Oh, that's going to freak you guys out, I know. How many x's do I see in there? None. So I can write it as 5x is 0. Is 0 a whole number? Yes. In fact, whole number, that's the way to remember. 0 is a whole number because 0 looks like a whole. So it is a whole number. So that's why the leading coefficient is 5. That's why it is a polynomial, because the only variable it has, which it doesn't, is to a whole number, which is 0, which means there are no variables in it. So if I see 11, is that a polynomial?
No.
Yes.
Yes.
That was the whole point. What it just said. Do you see any variables on the bottom? No. Do you see any variables that have a non-whole number power? And you're like, I don't see any freaking variables. Therefore, it doesn't go against any rule. So that is is specifically a monomial. Degree 0, because I see no variables.
Okay.
Degree is the total number of variables I see in a term. Yeah.
So this one, like
what
this.
about negative 7/3? Is that a polynomial?
Yes.
Totally, it's a number. Any number I write down, it's a polynomial automatically. It's the most basic polynomial. Any number you can think of. Is pi a polynomial? All day long. How about square root of pi? All day long. How about square root of pi to the pi power? All day long. It's just a number. I'm not going to do that to you, but sorry. I want some pie.
Are you waiting for more questions to be asked?
No.
Taking a break.
Yeah. Yes, go ahead. Sorry, kid. Go ahead. I like that. You're just sitting and taking a minute. No, come on. What you got? Or you just were checking in on me,
Yeah,
making sure I was
checking
all
in.
right? All right. Doing all right, Jeff? Yes.
5C
Is that supposed to be positive 6x? What did you do?
Where am I at? Nope.
No?
Because it's minus 3.
Yeah, but you're.
So when you distribute, let's see. 5C's got this dude. Where'd it go? That's what's- So this side looks great. I mean, somebody already factored that for me, right? But unfortunately, it is not equal to 0. Shit. So you actually have to unfactor this. Now, to do that, how do I multiply this out?
Minus 3, minus 3.
Because I got 2x minus 3's, right?
Oh, yeah.
I don't know why people write that.
No.
I have 2x minus 3's. No pluses in there. And then you FOIL it out, so what do you get?
2x squared.
X squared minus 3x minus 3x, there's your minus 6x. And then plus 9. So there's where the minus 6x comes from. And then you have to make it,
So we subtract x.
yes, you have to make it equal to 0. So you subtract x, subtract 9.
I remember I don't remember what section it is, but it's like where something equals 0 at the end.
Sure, yeah, that's section 6.6.
Can you do like a problem like that?
Sure.
Okay, yeah, sure.
And then minus x minus 9, minus x minus 9.
And then what do we do from there? Like, is that the answer?
Nope, because you know you're done with an equation when you have x equals something, or that there's no solution or something, right?
Okay.
So, what do I do with this?
Is this by factor?
No.
It's not prime.
GCF.
GCF saves your x, right? You always try GCF first. So the people that try to force it to do this, you're not going to get the right answer. You're going to guess at stuff, and it's not going to be right. What comes out of both? X.
X minus 3.
So then either
X equals 0.
either x is 0, answer, or
X
Plus 7.
so add 7 over, you get 0 or 7. If you plug it back into the original, it works. What's 7 minus 3?
4.
4. 4 squared is
16.
16. And what's 7 plus 9?
16.
16. So 16 equals 16, 7 checks. You guys see what I'm doing here? And when I put a 0 in, negative 3 squared is
9.
9, and 0 plus 9 is
9.
9. So 9 equals 9. So it works. So you can check those answers. Just put it back in the original. So I'm always curious how you guys study. Because homework is one piece of study. It's not study, right? Homework is one thing. So to study, the way I would do it is I would make sure I would go through all the ideas, right? Get all the ideas. So all the different forms of factoring, all the ideas I'm supposed to understand, and make sure I can just look at a list of them and go, I understand that. Do a problem like this and go, I understand that idea. I understand that idea, right? That is a good way. Just do an outline of all the ideas you're supposed to know, and then make sure you know them. So homework is where you get the practice of the ideas, but to study, you should say, what's everything I'm supposed to know? Do I know them all? So I think, like for example, on page 410, they have a chapter 6 summary. Every chapter has a summary. So that's where you get the outline of ideas. And then you just make sure, do I understand this process? Do I understand this process? But if you're at least doing the homework, okay, you're getting the practice. If you're not doing the homework, you should not be surprised if you're getting lower than you want. I don't know. That's been my crusade for a while, is to try to get students to understand homework, but I don't know if that's ever going to happen. It's not just me going, I was given homework, screw you guys, I'm going to give you homework. No, that's part of it. No. That's none of it. All right. Anything else? Yes.
For the test, is there going to be something that says that it's long division?
Let's see. How did I put it here? I just said simplify like 1J. It's because the difference between 1I and 1J, that's something I'm testing you on, is do you know when to break it up versus setting it up as long division? So I'm not going to say use long division to do the number. I'm going to say exactly like this. Simplify. So on 1J, you have to understand that requires long division. 1I does not require long division. In fact, you don't want to use long division on 1I. It won't quite work right. Yeah. I think people looking at me expectantly. I got nothing. I came here with nothing. It's all about review day. Is all about what you want to talk about.
Can you do I on form? Wait, let me see if I got the right answer. I don't know if I got the right answer, but
But you know, look at 4I real quick on the practice test. Do you guys understand what I mean by it's loaded with the same? It's loaded with B's and G. It's just screaming GCF to you. So that one's an obvious GCF. There's a bunch of B's and G's that they all have. And there's numbers in it, so that's a GCF. The thing to realize is you're not always going to be able to do a next step. So when I do that first step of GCF, I'm left with something that is unfactorable. I can't go any further, so I just stop after that one step.
Could we like do a regular factoring problem, but with like an ugly number in the middle? You know what I mean? Like
Yeah.
a number over like 100 or something. Because those are the numbers that like screw me up.
Okay. Let's start with one that's not as bad. Yeah.
This is easier than
And this one's not too bad. But this is where I want to show you don't just immediately give up because the numbers are good, right?
Yeah.
How can you imagine how many factors 2400 has?
A lot.
A lot. So I'm not going to do that. What's true about the two numbers though that I need?
negative.
They're both the same sign, and they both have to be. So what I'm going to do is I'm going to make this work first because I can make things add to be 100 easy, like 50 and 50. Add to be 100, right? If they're both negative, they add to be negative 100. And but what do they multiply to be?
250.
A little too much, right? So then 40 and 60, yeah. They make 2400, yeah. So I don't need to break the middle term up because it's a 1. I've got the two numbers, I'm done. X minus 40, X minus 60, yeah. That's what I would do. So in general, who asked that question?
Me.
Yeah. When the numbers are really huge, this is what I would do. I would start and make the middle term work first. Get things that add to be the middle term first. Right? So that was huge. Get to the wall, get the number. That sounds like Donald and Bernie together. Donald and Bernie, they merge. Get to the wall. Get out to 99%. What about that one? You would like it. But again, that last number is big. So let me start with the middle. You could totally just always do factors of 560 and then check to see if they add. You could always do that. What I'm suggesting to you is that list could be long, especially the big numbers I get. So what's true about the two numbers though? Whatever two numbers I want to try, they have to be what? Negative positive. They have to be different signs. You guys see that? They have to be different signs, so they multiply to be negative. So therefore, they have to subtract to be 73. One's going to be positive, one's going to be negative. So for example, 75 and 2. Don't they make 73? If it makes 75 negative, isn't that negative 73? But that multiplies to be what?
100 something.
150. Is that enough?
No.
Nowhere near enough, right? So I then make it bigger.
Yeah. So you
So maybe what?
increase that or decrease it. Make a higher negative.
Make it bigger because I want a bigger number, right? So don't tell me 70.
7. Just try 80.
80, and so what would this be?
You'd have to increase it by 5. Or
Sure. So it'd be
Well,
7. Doesn't that
yes.
make 73?
yeah.
So again, yeah, that went up by 5, so this has got to go up by 5, so they're still the same distance apart. They're still 73 apart. And what's negative 80 times 7? Negative 560. There you go. That, if my numbers are large, that's what I would do. I would attack the middle term first. Because when the numbers are large, this could have a very long list of factors. Right? And then it'd take a while to check every one. This is a little quicker in that respect.
So it would be x minus 80 plus x plus 7.
Careful. Times.
Times?
This is all about factoring, and factoring means they're multiplying.
Oh. But that's what.